Unit 2 vocabulary is a little different because they're using some kind of different words that are maybe a little bit more British, but we'll go through these pretty quickly. Our first one is what is known as indices, right? So indices are exponents, plain and simple, right? So you could see that in a couple of ways, like for instance, x squared, its indice is 2. The square root of x, its indice is 1/2. So it's some sort of exponent that's acting upon a variable. So it could be a letter, it could be an actual number, it could be a radical, it could be all sorts of things. So then we have surds, and these are irreducible values within a root. So, for instance, so the square root of 4 is not a surd because the square root of 4 is 2. The square root of 3 is a surd because it cannot be reduced any further. And so that is kind of the idea of what that is. So if you hear us use the term surd or irreducible, that's kind of what it's talking about. So we're going to be working around with these. So then we have rational numbers. And these are numbers that can be written as a over b, where a and b are integers. Okay, so anything that can be written as a fraction with integer values is a rational number. So the main irrational numbers are surds, they're irreducible square roots. But there are an infinite number of irrationals. But if we refer to a rational number, there are no square roots involved. So we've got expand. So usually that means apply an indice to a binomial or greater. You could also say polynomial as well. So an example of that would be, I might say expand x plus 3 cubed. Okay, well, expanding x plus 3 cubed is going to give me x cubed plus 3x squared plus 3x plus 1. So that is expanded. Now, if I say to simplify, simplify is going to mean to, try to collect terms and eliminate redundancy. So, it could be, some few different options. Might be something like x squared cubed. Well, we can collect this together to make x to the 6th. We might also see x cubed over x. Well, this can make x squared, right? We've got some redundancy there, so we're trying to get everything we can together and simplify it as much as we can. So rationalize. That means no roots in the denominator. So An example of that would be, if we have 1 over the square root of x, we would want to multiply by the square root of x to end up with the square root of x over x. See, no square root. So there's a couple of different ways that we would want to try to go about that, but that is what it means. And then finally, the last one is simultaneous equation, or equations. So simultaneous equations are 2 equations that have a common solution. So usually what happens is simultaneous equations, you might have lines, 2 different lines, and they're going to have an intersecting point. So for instance, if we had like y equals 5x plus 2 and y equals 3x minus 3, these can exist simultaneously, and so we could then say, well, 5x plus 2 equals 3x minus 3, and we can get 2x to equal negative 5, x to equal negative 5 halves. And then we can go back and plug that in to figure out what y is. So these are, we're trying to basically find the intersecting points of 2 lines.